Hello everyone. In this video, we are going to see about how to perform a Prim's algorithm. So first of all, why do you require Prim's algorithm? Have you ever wondered how a network like your electricity grid or internet cabling is laid out using the minimum amount of wire, but still connects everything? That's exactly what Prim's algorithm helps solve. And today we are going to solve the Prim's algorithm by step. In this video, we will understand what minimum spanning tree means and how Prim's algorithm works, and then we will implement it with real graph example. So let us start with the basics of a minimum spanning tree. A spanning tree, nothing but it connects all vertices in the graph with the minimum number of edges and no cycles. So this is a graph they have given. So this is the graph they have given. So from this graph, we will find a minimum spanning tree which connects all the vertices with minimum number of edges. And then it should be least total edge weight. That is meant by minimum spanning tree. And then we are going to achieve the minimum spanning tree by using Prim's algorithm. Prim's algorithm is nothing but it's a greedy algorithm. So where all the vertices will be visited and then we will not go back again. Okay. So here in the Prim's algorithm, we will use priority queue. So in the priority queue, this is the queue we have maintained. And then the queue is nothing but we have all the vertices. So always we will start from the arbitrary node, which is the least one. So here it's an A, B, C, D until I is there. So it's the least one is A. So you will start from the A node. So here VA is nothing but the vertex which we have visited and then extract minimum of Q. So whichever value is weight is minimum. Okay, since I am starting from the first onwards, initially I am going to start with the A. So the remaining all the vertices will be assigned with the infinite. So once I visit the nodes corresponding vertices, the weight will be gets updated over here. Okay, so we will see the one step by step. Then we will come to know that what's meant by infinite, what's a VA, what's a minimum of Q, all those things we will come to know. So the first step is going to be, we are going to see the first vertex called A. So where it has been connected, it is connected to B, it is connected to H. So what is the weight to the B? It is 4 and to H it is 8. So in terms of B, I will replace with the 4. Key of B is 4 and then pi of B is nothing but the origin of the connection between to the B is from A. And then key of H is 8 and then pi of H is nothing but the vertex which it is connected to the A. So both are A, right? So key of B. So A to B is 4. So pi of B is nothing but where it has been connected. And then what is the weight of the edge? Likewise, H is connected to the A and weight is 8. So in place of B, I have given 4 and in place of H, I have given 8. And then remaining all the vertices are having an infinite value. And where VA is nothing but the A has been visited. A has been visited. So now, what is the minimum in this queue? 4 or 8? The minimum value is 4. So we will extract the minimum of Q is B. So next we will start with the B vertex. At first we have visited the A. So now we will start with the vertex B. So B has been connected. So from B we will see. So from B where it has been connected, it is to C and it is to H. Okay. So here from B. So key of C is 8 and then key of H is, it is connected to H. But here the weight is 11. Here the weight is 11. But already to reach H, the weight is less weighted is 8 is already there. So I need, it's a minimum spanning tree, nothing but we need to construct a minimum spanning tree with a less number of weighted edges. So 8 or 11 is minimum. Which one is minimum? So 8 is the minimum value. So we will not change the value to the H. So because 11 is very much larger than the 8, so we will not change it. So now here C also having a value called 8 and H also having a value called 8. So how the C value of 8 comes? Because B to C, we have the weighted value called 8. So then VA becomes the vertex which we have visited are A and B. And then from this, which one is minimum? Both C and H are minimum. Both are same value. So we can take the C. We can take the minimum variable as a C. So next, from C, so that has been connected. So C to D is 7, C to I is 2, and C to F is 4. So these are the three vertexes has been connected to the C. So C, you can see here, key of D is 7, phi of D is already we know that where it has been connected. So likewise, key of F, it's 4, key of I is 2. So now from C, it is D, C to D is 7, C to F is 4, C to I is 2. So now what should I do it over here? So I will replace this infinite value with this values. In place of D, I will give 7. In place of F, I will give 4. In place of I will give 2. So you can see here D, E, F, G, H, I. In place of D, I have given 7. In place of F, I have given 4. And in place of I have given 2. So in the VA, we have visited the ABC. So what's the minimum value from this? I is the minimum value. So next I will start from the I. So from I, where it has been connected to the H, 7. But already we are having a value called 8. Okay, even though here the value of 8 is larger than the 7. So now what do I do it over here? So I will prefer this 7, less number of weight. 7 has been taken. And then from I to G, it is 6. There are two nodes only, but has been connected. So 7 and 6 for H. So from previously it was 8. It should be 7. It should be 7. It should be 7 over here. So now here, which one is minimum from here? The value called F is minimum. So we will take a F. So from F. So from F, where it has been connected to E and to G and to D. So key of G is going to be 2. Key of D is going to be 14. Okay, the 14. But already we have an less value with C to D is 7. So we will not change it. We will not change it. Okay, and then correspondingly F2 E, which is value is 10. Value is 10. So now I will update this Q. I will update the Q. So G is 2, and then E is 10, and then D is 7. D is 7, which is unchanged, Even though we have 14, but 14 is larger than the 7. So we are not changing that value. So what is the minimum value from here? It is G is the minimum, 2. So G is the minimum. So now next we will visit the node called G. So from G, where it is connected to the H, the value is 1. So to H, I can come by 8 or 11 or 7 or 1. Which one is minimum? So 1 is the minimum. So I will change the key of H to the 1. Previously the key of H is, what is the value? 8 is the value. So now I'm changing to the 1, which is less weighted. Already always we require a less weighted edges. So key of H becomes 1. So now what happens over here? The H value has been updated to the H value as a new value as a 1. And the VA, whichever vertex has been visited, we have been keep on updating. So from this, which one is minimum? H is the minimum. So now here from H, what happens over here? All the nodes are visited. So H to A is visited, H to B is already visited, H to I is already visited. So there is no vertex to be solved from the H. So from D comma E, which one is minimum? So D is the minimum. D is the minimum. So from D, I can reach the E with the value called 9. With the value called 9. But here I'm having a value called 10. So I can update the value of E with the 9. So E with the 9 has been updated. So then minimum is E. Next one is going to be E. So the final graph is going to be A, B, B to C, C to I, and then it's going to be C to F, and G to F to G, G to H, C to D, and D to E. This is going to be the final minimum spanning tree. So the minimum spanning tree is nothing but which connects all the vertices with the less number of weighted edges. You can see here A to B is 4 and B to C is 8 and C to I is 2 and then C to D is 7, D to E is 9, C to F is 4 and F to G is 2 and G to H is 1. This is the minimum spanning tree. A minimum spanning tree is nothing but which connects all the vertices with the less number of weighted edges. That's a minimum spanning tree. This algorithm, the method which we have used over here is called an Prim's algorithm. The Prim's algorithm is nothing but greedy algorithm. A greedy algorithm is nothing but where we will keep on visiting the nodes one by one. Okay, thank you for watching.